What's going on, my ASVAB party people? My name's Coach Anderson, and welcome into our class recording. So basically, with distance rate time, do you ever find yourself knowing the formula, but having no idea what to do when you're actually using it in a word problem? Well, that happens to a lot of people, not just you. And what we're gonna do in this video is a class recording 2 hours long where I show you that the formula, memorizing it, it's not enough. I'm gonna show you how to actually break down the formula in the word problem so you can understand what you need to do with it. Specifically in this class, which is a pretty exciting one, we're going to be looking at test level questions that have you go through what if you have two situations with their own rates and times. How do we handle those problems? So if you're ready to get started and raising your score, my party people, then let's get to it. Watch all the way to the end. That way you can raise your score and get that job you want. Only thing I ask is that if this helps you out, just subscribe to the channel, drop a comment, and we're all good. As always, my party people, I'm Coach Anderson. Always a blessing to be your ASVAB coach. Let's get started and let's ace the ASVAB. So welcome in everybody to part 2 of distance rate time word problems. So for those of you that were here yesterday, welcome back. For those of you that weren't, no worries at all. So even if you weren't here in yesterday's class, you're still fine. You're still going to be able to learn what we're doing today. So no worries at all. But here's the game plan. First things first, we're going to take a couple of minutes, maybe like 5, 6, 7 minutes, to go ahead and just refresh on that formula. So everybody in the chat box, give me a yes or a no. Do we at least recognize this formula, distance equals rate times time? Awesome. Sounds good. So if you can at least recognize it, I can do my job and take you a step further because we're going to go over each component. So beyond just recognizing it, everybody, another yes or no question. Beyond recognition, do you know how to identify each of these pieces in a word problem? Do you know how to properly identify a distance, a rate, and a time in word problems? I already have people also shouting out some of those keywords as well. So for rates, yeah, the keyword per, like miles per hour, that's definitely going to be a keyword that's going to give away that you're dealing with a rate. Absolutely. That's right, Ken. Exactly. So we're going to review again the formula itself, how to point things out on word problems, and then we're going to move forward because yesterday we talked about having multiple rates for one event. And now today, we're going to be talking about multiple events with the same object. So that's what today is about. And don't worry, you're going to recognize the questions as soon as we get to them. But with that said, main formula, let's go ahead and review this, do some quick calculations just to refresh on how to work forward and backwards. And then we're going to talk about what today's class is all about. So with that, my party people, let's go ahead and write this down if you haven't done so already. Distance equals rate times time. And so let's go ahead and go over a couple of examples. So let me make sure that's still in frame. Perfect. Now let's go ahead and say we have an example where the distance that we're given is not known. The rate that we're dealing with is 47 miles per hour. And the time frame that we're dealing with is, let's say, 8 hours. My party people, here's what I want you to do first in the chat box. What I want you to do first is go ahead and set up the formula for me. Don't solve it. Don't multiply, divide, don't do anything. Just set up the formula. Take this over here and replace the parts that I gave you into the right place and type that out in the chat box. Also, Zubair, I saw your question and a couple of other people asked already. So I already recorded that video. We actually have it slated to come out on our YouTube channel on Sunday. So just go ahead and put a reminder in your phone. The video solution to that problem, it's going to come out Sunday at 10 a.m. on YouTube, Eastern time. So I know that's a little bit of a wait, but if you do want it earlier, just go ahead and shoot me a text. Just hound me over text because I do already have it uploaded to another website. So I can just actually share that link with you. So just go ahead and reach out to me if you really want it before then. I got you. But appreciate everybody in the chat box. Looks like we are understanding how this setup is supposed to go. We are looking for the distance. So I'm going to keep that as D. The rate that I'm given is 47 miles per hour. And then we want to multiply this by the time, and we are given the time, which is 8 hours. So once we do that, we'll go ahead and take 47 multiplied by 8 to see what this is going to be. So we have 7 multiplied by 8. That's going to be 56. Carry the 5. And then we have 4 multiplied by 8, which is 32. Carry the 5 is 37. So everybody, my final answer is going to be 376 what? 376 what? Nope, not miles per hour. Nope, not feet. Remember, everybody, that rate is going to tell you what your distance and your time are. If my rate is 47 miles per hour, hey, this last part, that's your time. Hours, that matches up. Miles per hour, that first part, that tells you what your distance is. Miles, right there. But part of people, does that help anybody out in terms of understanding the pieces of the formula? Remember how I talked to you about, hey, we have to make sure that those units match up. The rate gives it away. If it's miles per hour, that's distance per time. That's how it's written. Got you. Right on. So with that, that's going to be 376 miles. All right, so let's take a look at another example here. The next example is going to be where, let's say we're given the distance and we're trying to find the rate or the time. What are we supposed to do there? So in this example, let's go ahead and draw a little horizontal line. And let's go ahead and say that we have a distance given to us of, excuse me, a distance of, let's say, 22.5 miles. And then let's say we're given a rate that is unknown and a time value of 9 minutes. All right, my party people. So when we fill in our formula, I want you to go ahead and do that for me. Go ahead, write that formula out for me in the chat box. I see so many of you guys already know what you're supposed to do, but I want to see you set it up correctly. Yeah, there we go. I love seeing that. I want everybody to go ahead and do that as you get the moment to do so. When we fill in our formula, distance equals rate times time. My distance that I'm given is going to be 22.5. So I'll write that out. 22.5 equals my rate, which I haven't been given a rate yet. So I'm just going to write R. And that's going to be multiplied by the time, which is 9 minutes. So if you have 22.5 equals R times 9, there you go. But my party people, you've already said it. You know, we have to go ahead and work backwards here because I don't know what the rate is. And to get the rate by itself, I got to get rid of that 9 right there. So to get rid of that 9, I look at what operation I'm dealing with. That is multiplication all the way. So we have to go ahead and divide both sides to undo the multiplication. We divide both sides by 9, just like so. And we're good. Once we do that, we'll get R by itself and we'll get our answer. Is anybody here nervous about dealing with this decimal? Ronnie, I love it. Immediately, nope, no nervousness. But hey, some people may very well have to deal with that tiny bit of anxiety that comes with it. So remember, everybody, whenever you feel that you get a little hesitant around weird numbers or weird math symbols, remember that that always comes down to experience and practice. The lucky or the good thing about working with numbers and symbols is that they don't change. Like the way that they work does not change. So with that, I really want to beg you to take the time to practice adding, subtracting, multiplying, dividing with decimals, with fractions, large numbers, negatives. Put yourself in the position to succeed. So that way, when we're doing these word problems, we're not distracted by the numbers. We're worrying all about the main idea, the setup, the context, telling a story, because we know that once we get to the math, we know we'll have that down. So everybody, Just want to make sure I say that one more time. Please make sure to finish the math basics first before jumping into the arithmetic reasoning and math knowledge in the program. All right, so let's go ahead and divide this here. We have 9 going into 22.5. And all you have to do here is put that decimal in the same place that it was. And now let's go ahead and get it done. 9 goes into 2. It doesn't. 9 goes into 22. That's going to be twice. So we'll put 2 right here because 9 times 2 is going to be 18. Subtract that and we'll have 4 left over. And then from there, we'll drop the 5. 9 goes into 45. That's going to be 5 times. And that's a clean 5 times because that's a clean 45. No remainder, and we are good. So in this case, our answer for the rate is going to be the rate equals 2.5 what? Who knows how to tell me the way we should write this rate? Sid, that is correct. Those of us that are saying miles per hour, that's going to be incorrect. Remember, everybody, your rate is going to be your distance per time. So with that, when you look at your distance, you have miles per your time is minutes. So in this case, it'll be 2.5 miles per minute. My party people, does that make sense to you? And this is one of the biggest things. We have to be able not only to understand the numbers, but what the numbers mean. If all you're focused on is the numbers, well, then all you're really doing is trying to memorize a process without truly understanding it. And what happens in that case is the moment that we present it in a slightly different way, you end up getting even more anxious and freaking out and then hoping for the best and singing a Hail Mary there. So we don't want to put ourselves in a position to freak out like that. What we want to do is understand via confidence, building that nice and slow. So I'm going to zoom on out here. I'll give you a chance to screenshot this, my party people, because now we're going to move it right along into today's main topic, which is dealing with not 2 objects moving at the same time, but 1 object moving multiple times. So when you are ready, everybody go ahead and type ready in the chat box, and we're going to move it on over in just a few moments after some folks here get their screenshots in. Right on, right on. So let's go ahead and take it over here in 3, 2, and 1. So today's focus, again, like I said, 1 object, multiple events. Yesterday was all about 2 objects moving in 1 event at the same time. But now it's going to be 1 object moving across multiple events. So here's an example. And y'all tell me if this is a recognizable story. Don't worry about the numbers. Tell me if this is a recognizable story. So here, if we drive 20 miles an hour for 3 hours, then 50 miles per hour for another 2 hours, then we've driven a total of 160 total miles. Does that situation sound like something you might come across on the ASVAB where they don't give you one of these pieces of information, where they say, hey, you drove 20 miles an hour for 3 hours, 50 miles an hour for 2 hours. How many total miles did you drive? Or what was your rate for the first leg? Or how long did the entire trip take? Right? This is the scenario that I'm presenting to you, where you have what's going on right here. Check this out. What we have are 2 events for the same object. So allow me one moment to draw these little rectangles here. And allow me to duplicate this. Perfect. And then let's go ahead and change some colors up. That way it makes a lot more sense visually. So give me one moment here, everybody. Let me take this one and we'll go ahead and make this one just for ease's sake red. And then we'll make this one blue. So here's what's going on, everybody. I'm going to highlight the first part here in red, 20 miles an hour for 3 hours. And then in blue, I'm going to highlight this over here, 50 miles per hour for 2 hours. And then the total distance. Everybody give me another color here besides red or green. Someone shouted it out. Go ahead. Green, appreciate you. Okay, I'll go ahead and take the green right here. So we'll go ahead and draw this out. That didn't work the way I wanted it to, so allow me to just to duplicate this. And let's change that color up to green. All right, so with that said, there we are. Let's go ahead and extend that from here all the way to here. And let's highlight this right over here. All right, so if you like color coordination, then you might be able to tell where this is going. So let's take a look at the 160 total miles. That's the entire trip. And then everybody, the red and the blue represent the 20 miles per hour for 3 hours and the 50 miles per hour for 2 hours. Before I continue, does everybody see what I'm seeing right now? Again, this representing the red, this representing the blue, and the green is everything all together, the total distance. All right. So with that said, everybody, let's just prove that the red part and the blue part, let's prove that this actually adds up to 160. So everybody in red over here, help me out. If I want to find the distance for this part right here, then I'm going to have distance equals my rate, which is 20 miles an hour, times the time, which is 3. Everybody, my distance for that red piece is going to be, appreciate you, Ronnie. That's going to be 60. Thank you, Nick. There we go. 60 miles. Let me write 60 miles right there. Nice and easy. Now let's go ahead and continue on by representing the 50 miles an hour for 2 hours. So we have a distance here of rate times time. So 50 miles an hour multiplied by 2. Everybody help me out. 50 times 2. Thank you. The distance there is going to be 100 miles. So everybody, if we double check our work here to make sure that this all makes sense, is this true? Is this, do we understand how we get the total of 160? We add the distance for the first part of the trip with the distance from the second part of the trip. And that's what's going to give us the entire trip. Exactly. 60 plus 100. That's what gives us the 160. We connected the distances. We said the distance from the first leg plus the distance for the second leg equals the entire total distance. I want everybody to go ahead and hit me in the chat box. Give me a yes or a no if that makes sense. And if you want to take a screenshot, as always, you're at liberty. My only regret is that I'm not on camera today to make the funniest face I can, but no worries. All right, perfect. A few more moments. All right, so my party people, when we want to understand this in a more technical way, and this is how the success in these classes really comes about. We can talk about things making intuitive sense, but once we start understanding things in a mathematical sense, that's when things become a lot easier for us. So I want to just express what we just did. Allow me to move all of this up here because I want to express everything that we just did, representing this over here. So everybody, isn't it true that we basically just said that the first distance plus the second distance, I'm just going to use the numbers 1 and 2 to just give myself identifiers. The color should make sense too, but I'm going to say the first distance, the second distance, we add those together and we got the total distance. Everybody, isn't that true? Isn't that true? All right. So my party people, look, if this makes sense, if this right here makes sense, what I'm about to do next should just be literally one tiny step in front of that. I promise you, this is the most important part of today's class. So my party people, in the chat box, pop quiz, what is the formula to find the distance? What are the two things that you need to multiply? Show me, write it out for me. What do we do to get the distance? Ben, lightning fast. Appreciate that. Alexa, thank you. Tyler, thank you as well. We get the distance by multiplying the rate times the time. So this is all I'm saying, my party people. If you are in today's class and you're looking through these situations, oh, we went this fast for this long, this fast for that long. Some of y'all might think that just because you see two rates, you have to add the rates. No, that's not the case. Look at what happens when I replace the distance with what it is. We have the rate times the time for that first distance plus the rate times the time for that second distance. That's how you're going to get the total distance today. The reason, everybody, the difference between yesterday and today is that those objects in yesterday's class, those objects were moving at the same time. So yes, they were covering distance together. That's not what's happening here. You're talking about the first event, the first leg of a trip. With the second leg of the trip, you add those distances together. So this is what the formula will actually look like when we're dealing with one person and two events that they went through. My party people, do we notice the difference between this and just adding the rates or subtracting the rates like we did yesterday? And you don't need to answer if you weren't here yesterday, but you guys let me know if you see that there is at least a difference here. Right on. So yeah, I definitely understand that some of us were, ready as soon as we see two rates, we want to add or subtract, but it really depends on the situation. Again, in yesterday's class, you are looking to add or subtract rates if you have these two objects moving at the same exact time. That's the only case where you add or subtract the rates. In today's class, we're talking about one person moving now and then moving later. Those are two events for the same person. Different scenario, different way we represent the story. The story is the first distance plus the second distance is the total distance. That's it. That's it. And so when we try to fill this out with the pieces we have, we will fill in the rate and time for the first scenario, second scenario, and we still get to solve the equation nice and easy. Is anybody here ready to try some problems out? Right on, right on. So it's 6:30. We have about 90 minutes. We should definitely be able to get through the first 8 of these test level questions. So let's go ahead and give it a shot today. If this is your first class with me, my party people, good luck. I'm kidding. I'm kidding. If this is your first class with me, obviously welcome in. And the one thing I always say is just do your best. Just do your best. Because remember, as long as we're putting that best foot forward, we can learn from those mistakes and we can give ourselves the chance of getting a higher score. So give it your best shot. Have your notes there in front of you. And the one thing I'm going to say for the people who've been to more of these classes, remember that once you get to the point where you're feeling confident, put those notes away. Try to do the next problem without your notes. See how much further you can get on your own. Everybody, does that make sense? All right, perfect. Well, I'll set this timer up. I want everybody to reply. Let me set this timer up for 3 minutes per question. And there it is. And now we'll have the timer show up at the bottom of the screen there. Perfect. All right, here we go, my party people. When you have an answer, just type ready in the chat box. Do not reveal your answer, but here we go. 3, 2, and 1. And looking at our final 4, 3, 2, and 1. My party people, go ahead, put those answers in, If you're taking a guess, go ahead and put a question mark next to your answer. There's no shame in taking a guess, but just give yourself every opportunity to try to get a question right. That way we can practice like it's the real deal. So with that said, everybody, who here feels like going through those main notes and showing you how the formula is going to be interacting today, who here feels like that really gave you an advantage with this first question? And you can be honest, say yes, say no, yeah, it's all good. Looks like there's plenty of you that feel like, yes, this really did help you out. And I love hearing that because that's the point of going over the main idea. But I really want to make sure that I'm getting an honest look here at what y'all think. All right, so let's go ahead and give it a shot here. Let's get the timer out of the way. All right, and let's get it going. So first things first, everybody, we want to read the question. For those of you that are here for the first time, again, first thing we want to do, not read the problem start to finish. No. We want to start right here, the question sentence. So it's asking us, what is the total distance the cyclist traveled? All right, everybody, before we begin, is it clear to you, whether you got the problem right or wrong, or if you feel like you got it right or wrong, do we understand that the goal of the question is to find the total distance? That's the first step. Now, it doesn't matter how anxious we are. It doesn't matter how anxious. Everybody here can go to the question sentence and understand, hey, what's the goal? I'm not asking you to, tell me exactly how to do it. No, I'm asking you to tell me what the question is telling you to find. Because once you understand the goal, then all of the information that comes before the question makes a lot more sense. Watch, think about it like this. I want to find the total distance for the cyclist. Okay, so it sounds like we have somebody cycling and they're going places. Let's go ahead and read the information. A cyclist rides for 3 hours at a speed of 15 miles per hour. The way that you should be reading it over time is not focusing on the 3 or the 15, but recognizing that they tell you that this cyclist rode for a certain amount of hours, so a certain amount of time, and they tell you the rate at which they're riding at. We have time and a rate. And then the next sentence says, she then increases her speed to this rate for this amount of time. So if you notice, they gave you one event right over here, 3 hours at 15 miles an hour. And then we have another event right over here. She then increases her speed to 20 miles per hour and goes for 2 more hours. My party people, does it make sense here that we have 2 events for the same person, one after the other? Perfect. As long as we understand that premise, then what we're going to do here is going to make a lot of sense, because the total distance is going to be the first distance plus the second distance. And let me use a blue highlighter to show that for the second one here. And so that'll be the second distance. So everybody, do you understand that what we're about to do is we're going to calculate the first distance with the rate and time from that scenario. Then we're going to find the second distance with the rate and time from that scenario. Does everybody see that coming? Again, yeah, because this is the basic way to say it, right? Total distance. Well, the first situation's distance plus the second situation's distance. That's pretty easy to say. But can you get granular? Can you actually do it? And that's what we're doing now. We see that we're going to have 3 hours at a speed of 15 miles an hour. So that's exactly where the 15, that's the rate, multiplied by time 3 comes in. And then for the second distance, everybody, what are the numbers there? What's the rate and the time for that one? Right, 20 miles per hour for an additional 2 hours, so for 2 more hours. So 20 rate, 2 is time, and there we go. So that's how, again, we're going to get that total distance. So now let's go ahead and do some math. So let's go ahead and grab this again. Put you right there. And here we go. Everybody, 15 times 3, what's that going to be? Yeah, that's going to be 45. 3 times 5, that's going to be 15. Carry the 1. 1 times 3 is 3. Carry the 1 is 4. So that's going to give us 45 miles in this case. And then we have 20 multiplied by 2. We don't need to do that on the side. Everybody, what's 20 times 2? Yeah, that's going to be 40. Nice and easy. So what this represents, before we get the final answer here, this is the distance for that first leg, 45 miles. This is the distance for that second leg, 40 miles. We add that together to get the total distance, and we get what, everybody? Yeah, that's going to be 85 what, though? 85 what? Remember, the distance is just a single unit. The time is just a single unit. The rate is 1 unit per the other. So is it going to be miles per hour or miles? Yeah, there we go. It's going to be 85 miles. There we go. And we are set. My party people, how are we feeling about this first one here? Answer choice that's correct is C. How are we feeling? Oh, I saw some light bulb moments there. I see that you're messaging me privately, so I won't mention your name, but I love seeing the light bulb moment right there. And I see a lot of people here feeling good about what's going on. Townsend, hey, look, there's a teacher out there for everybody. I'm just glad that this group right here appreciates and can learn from the way that I teach. That's all it is. There's somebody out there for everybody. So let's go ahead and try out the next one. Let's go ahead and give it another 3 minutes and let's see what you got, my party people. So here we go. Let me get that timer up for you. And then let's go ahead and move it on forward in 3, 2, and 1. And again, don't share those answers until the time is up. Just type ready when you're ready. How are you feeling so far about these, my party people? Hopefully you're feeling well. And in case you didn't know, my ASVAB All Access program, that's how all of my students get rid of that test anxiety, clear the confusion, and get the scores that they want. So if you're interested so far, continue on with this video, but at the end, make sure to shoot me a text and click the link in the description of this video. That way you can see how thousands of my students have raised their scores with me. It'll include all the classes and the recordings to them, and so much more that I'll be telling you about later on. But for now, keep enjoying this session, keep putting in the work. You got this. And looking at our final 10 seconds here, my party people, feel free to put those answers in. If you're taking a guess, feel free to put a question mark next to your guess. I got you. All right, sounds good. And again, question mark next to those answers if you are taking a guess. No shame in that. So let's go ahead, get this timer out of the way. Let's get to business here. So who is, or actually, let me give it a little more range here. Where's your confidence at? Scale of 1 to 10, with 1 being, I want to just leave right now because I am not understanding what I'm doing at all, to 10 being, the utmost confidence with this specific question. How are we feeling right now? Okay, that's a lot of 8s and 10s, 8s, 9s, and 10s. That's a lot. Okay, but either way, whether you're at a 3, a 5, or a 10, remember that we're trying to get a little better every single time. So as confident as you feel, make sure that you're trying to learn one little bit more. So let's get to it. First things first, read the question. What is the total distance Sarah cycled over these 2 days? So before I begin, yes or no in the chat box, we are looking for the total distance that Sarah cycled. Right on, right on. That is correct. We are looking for the total distance. And so how are we going to get that total distance? That's the big question. Let's read through the information and try to find out. So Sarah is training for a triathlon. On Monday, she cycled at an average speed of 15 miles per hour for 2.5 hours. So she did an average speed. So this is a rate and this is a time. All right, sounds good. On Tuesday, she cycled at an average speed. Okay, that's a rate right there. And then there's a time right there. So if I want to get the total distance, it really sounds like I need to take the distance from the first day, add that with the distance from the second day, and I'll be good. Yes or no? Do you agree, my party people? Do you agree? All right. So with that, if we're in agreement about the context, about the story and how things play out and line up, let's get to work. So I'm going to begin by highlighting day 1 in blue, and that's going to be Monday. So she cycled at an average speed of 15 miles per hour for 2.5 hours. So if I'm writing out that distance and I replace it with the formula, because again, remember everybody, distance equals rate times time. So I'm basically taking the distance that I see, replacing it with rate times time so I can figure out what it is. So right over here, the rate was 15 and the time was 2.5. And so before we do the math, we're just going to lay that out right there. And we're going to lay out the second one, the second day. I'm going to highlight that in green for day 2. And that's going to be again Tuesday. The speed was 18 miles per hour and the time was 2 hours. So now that we have that, we'll go ahead and do 18, multiply that by 2, and it looks like we're pretty close to having a final answer here. So first things first, 15 times 2.5. This is where some people that are a little nervous about decimals will probably try to duck this question, but it's all good. Help me out, everybody. Remind me, when we are trying to multiply decimals, so let's say 15 multiplied by 2.5, what's the first thing we do, everybody? What's the first thing we do when it comes to multiplying decimals? Yeah, forget the decimal. Appreciate you, Angelique. Forget about it. Ignore the decimal. It doesn't matter. Just multiply. Step 1, again, just multiply. Let me go ahead and write that right here. Ignore decimal. And then we're going to bring back that decimal at the end. So bring it back at the end. So step 1, we're just going to go ahead and go through it. 5 times 5 is 25. 1 times 5 is 5. Carry the 2 is 7. Next line, now that we're dealing with the next place value, that's why we placed that 0 right there. So then we have 5 times 2, which is going to be 10. And then we have 1 times 2, which is 2. Carry the 1 is 3. So we have that there. Add this all up, and we will get 5, 7, 3. And so that was step 1. Step 2, when I say bring it back, we are going to say, hey, we moved one decimal place over. And so we'll bring it back one decimal place. So that'll be 37.5. My party people, are we good on that? Yes or no? Before we continue to 18 times 2. Sweet. I love the engagement. There we go. Now we're coming alive. So next up, we have 18 multiplied by 2. We get that done. That'll be 36. And the way that I got 18 times 2 is right here. The speed of 18 miles per hour for 2 hours. So that's where that comes in. 18 times 2, the rate times the time. That's what distance is, the rate times the time. So we have 18 times 2. 8 times 2 is 6. 1 times 2 is 2. Carry the 1 is 3. And that'll be 36. And now that we're here, the last thing we have to do, oh, it's all good. The last thing we have to do is add these two values together, which shouldn't be too crazy, shouldn't be too difficult. So we'll write out 37.5. And then we'll write out 36. And you can just put the decimal if you want to, that's fine. We add everything up. We'll have 5 plus 0, which is 5, 7 plus 6, which is going to be 13. Carry that 1. 3 plus 3 is 6. Carry the 1 is 7. So 73.5 is the total distance, which would be 73.5 miles. Let's go ahead and write that out correctly. Miles right there. And so our correct final answer is C. My party people, did we verify? Did we increase our ability to explain how to get this done? How are we feeling? I love it. I love seeing that confidence, everybody. And so obviously, there's nothing better than to meet your confidence with a slightly different question. Let's see what happens to that confidence when I'm warning you already. This next problem, I'm not going to have you solve for the total distance. I am not having you solve for the total distance. So get ready for that, okay? Get ready for that. No. I'm not going to try to give you some crazy numbers yet. Don't worry. I want to focus on the concept first. But get ready. So you are still working within this same exact formula. That's what today's scenarios are about. We have one object going through multiple movements, one then another. That's how we represented it. You can still do that with this next one, but I want to see if you can handle how to point out different things in different places. So here we go, my party people. 3, 2, and 1. And Ronnie, perhaps later on, once we are getting a rhythm going, maybe. But for right now, I want to give everybody the opportunity to really dive into the concept. All right, looking at our final two, 1, and time. My party people, go ahead, put those answers in, and put a question mark next to your answer. Do it gracefully if you are taking a guess. There's no shame in taking a guess. As always, everybody, I want you to be as confident as you are and admit that, and it's all good. So yeah, if you're confused, go ahead, type it into the chat box. I really want to get a good look at how many people here feel like this is a little too tall of a task right now. And then after we're done with this explanation, we'll see how you actually feel, and then we'll try a similar one out. I want to give you a chance to see what growth really looks like in real time. So let's go ahead. Appreciate that iPhone, no shame at all, right? No problem at all. So as confused as anybody could possibly be about this question here, do you know what the first step you need to take is? Everybody hit me in the chat box. What's the first step I need to take? No matter what, if it's easy or difficult, what's the first thing I've taught you to always do? That's right. Read the question. You might see an acronym RTQ, but yes, read the question is the first thing that you need to do. So what I'm discussing here is the question sentence. How many hours does she spend writing on the second day to complete the total distance? Okay, so again, be very, very specific. How many hours on the second day to complete the total distance? Did anybody here think that we were trying to find the distance? Did anybody here think that we were trying to find distance? All right, cool. Just making sure. There's typically going to be about 1 in 20 that might get confused on that end, but no worries. So how many hours? Boom, right there. We're looking for time. And specifically, we're looking for the time on the second day. My party people, are we good on that? We want the time, but specifically for day 2. That's what we want, blank hours. So no matter how easy or as confused as you might feel, this is the first step. Anybody can do that. Now let's gather the information we have, something that, again, anybody can do. The difficult part comes when you're trying to understand the connection between what you're looking for and the information that they give you. So give yourself a clear chance to write down the information clearly, point out what you're trying to look for, so that the rest can hopefully come more naturally. Here we go. A cyclist participates in a 2-day charity ride covering a total distance of 180 miles. Okay, cool. So we'll say total distance equals 180 miles. Sounds good. We have that right there at the top right. So on the first day, she rides at an average speed of 15 miles per hour for 6 hours. On the second day, she goes ahead and maintains an average speed of 20 miles per hour. But notice how they don't give us a time. My party people, do you notice that they're having us look for the time because they don't give it to us here? Do we see that? Do we see where the missing piece of information actually is? Perfect. All right, so let's get this done. Remember that what we said was the total distance is going to be the first distance plus the second distance. That's how we're going to get it. So what was the total distance? Well, that's going to be given to us right over here. Total distance of 180 miles. So this right here, that total distance, that's going to be 180. Next step, we're going to understand that first day's distance. Let's figure out how we're going to represent that. Well, on the first day, let me go ahead and use a blue highlighter right there. So here's the first day in blue. We see that we have a speed of 15 miles per hour maintained for 6 hours. So when I write out the rate times the time, that's going to be 15 times 6. Do y'all agree or disagree? Right on iPhone. I love the light bulb moment right there. That's why I love taking my time through these explanations, because I want to make sure everybody has a chance here to make sense of what's going on. So yeah, we have the 15 times 6. So before we do any math, again, let's make sure we have that setup done correctly. So now when we look for the second day, so let's go ahead and highlight this in, let's say, purple. So for the second day, we see that we have purple right there, and we maintain an average speed of 20 miles per hour. And we don't have the time for the second day. That's what we're looking for. So I'm going to write in the rate times the time, and it's going to look a little like this: 20 miles per hour multiplied by the time that we're looking for. So I'll just say T for time. My party people, with everything set up, does this look solvable to you? You tell me, does this look solvable to you? I love seeing it. Yeah, now it does, right, Phil? Now it does. So here's why this actually is solvable. This is the same scenario that we've been dealing with in today's class. The first two questions involve this, where the total distance is going to be the first distance plus the second distance. This here, I know that this makes sense to the vast majority of us. Now, if you have a question on where the heck this comes from, well, all I did from here down to here, the only difference is I replaced the distance with the formula. Remember, everybody, as always, distance equals rate times time. So if I'm trying to explain or show the first day's distance, I can just multiply the rate and the time for the first day. And that's right here. First day, 15 miles per hour. That's the rate, miles per hour. And then the time is 6 hours. So that's where that comes in. I'm going to find out what the distance is by multiplying the rate times the time. That's where that comes in. For the second day's distance, again, if I want to find that, I'll represent that as the rate times the time, but for the second day. Second day speed, 20 miles an hour. And we're looking for the time, how many hours for that second day. So this would actually make more sense if I said how many hours for the second day. If I change that to purple, that would make a lot more sense. So for those of us that said no, that it didn't previously make a lot of sense, you tell me right here, does that now make a little more sense in terms of just replacing the distance with the rate times time to figure out what it is? Let me know in the chat box before I continue. I got you. Second guess yourself, Alexa, no worries. And even if we're not at that peak place of total understanding, don't worry. It takes time, it takes repetition, because we're going to have another one right after this to give it a shot. But here we are, everybody. Now it's time to go ahead and see how much easier this is now. So let's go ahead and rewrite what we have. 180 equals, everybody, 15 times 6. Let's figure out what that is right over here. Or you can use some mental math. If you've seen my mental math multiplication video, 10 times 6, 5 times 6, that's going to be 90. But we can do 5 times 6 is 30. And then 1 times 6 is 6, carry the 3 is 90. So we have 90 right over here. Let's use blue again. And then we're going to add what 20 times t is, which is just going to be written as 20 times t. So 20t. So now that we're here, my party people, it's time to solve. This is an equation. We have to figure out what t is, but to get it by itself, we got to deal with the 90 and we have to deal with the 20. Everybody, what's the first thing that we're going to do? Which one do we get rid of first, the 90 or the 20? Which of these do we get rid of first? Yeah, the first thing that we're going to get rid of here will be the 90. It'll be the 90. So if nothing else, if the technical terms don't make sense to you, the way you want to think about it is you take away the furthest thing from the variable first. The 20 and the t are attached to each other. What's away from it? The 90. So that's the layman's terms way of saying it. The more technical way of saying it is, hey, what we're going to do is work backwards from the order of operations. If you knew what t was, you would multiply by 20 first, and then add the 90. So since we're working backwards, because the last thing we would have done is add the 90, the first thing we'll do working backwards is subtract the 90. So if either method makes a little more sense to you, I'm happy. If not, don't worry at all. You're in the program, the Math Basics, Unit 7, that's all about solving equations. So I want to make sure that you know exactly where to go to get help if this part of the solution process doesn't exactly make total sense. I still want you to succeed, and I want you to understand that if you're understanding this up here, you're doing a great job so far. This is the actual calculation part. I don't want you to feel bad if you're not 100% confident on this. So here, let's solve this here and keep it moving forward. First step, subtract 90 on both sides. Right there, cancels out. And then we're going to get 180 minus 90. That's going to end up being 90. 90 equals 20t. So the last thing we need to do is go ahead and divide both sides by the 20. That's the opposite of multiplying by 20. So allow me to move this over here. So 90 equals 20t. Divide both sides by 20. And what that's going to give us cancels out on the right side. And so we're going to have 90 divided by 20, which is going to be the same thing as 9 divided by 2. And that's going to be 4.5. Or another way to write it, if you want to just see the long division behind it, 2 goes into 9. That's going to be 4 times. Subtract the 8, put a decimal place. And then that's going to be 10. So 2 goes into 10 5 times. So that's what makes t equal 4.5 hours. And there we go. Boom, green highlight, and there we are. So my party people, y'all let me know, does that make a little more sense to you? If you want to see this in a much, much more basic way, it'll take this first understanding that we had. But long story short, all we did was, hey, we're trying to find the time for the second day. All we know is the distance for the both days together and the first day as well. So we just took away the distance from the first day. That was 90. We just took away the distance from the first day. And that left us with the second day's distance, which allowed us to use distance equals rate times time. So either way, again, I'll help somebody some way here understands this in at least one way. But with that, are we ready to try another one out? Oh yeah, let me go ahead and highlight the answer there, 4.5. Let me make sure I don't duck any questions. Let's see what we have. So Jesse, is there another way you could have done it? Or did if I plugged in a different number? So this is actually the standard way this one's going to be done. All I did was represent the word total with addition. That's really all we're doing today. Like, that's all I did. In today's case, the word total distance across 2 events means we add the distances. When we're talking about the other scenario where it was objects moving at the same time, we typically can only work with adding the rates or subtracting the rates. So again, just making sure I'm showing the differences between yesterday and today. And even if you weren't here, still making sure that you're good. All right, so let's go ahead and give it a shot. Let's give another one a shot. That was funny, Angelique. I need to hear your voice on the ASVAB and I'll be fine. I have had reports of people saying that they've heard my voice in their heads reciting formulas and saying, read the question. So, I guess if it helps you succeed, then I'll be okay with it. So here we go. Let's get the timer up and let's start the next question in 3, 2, 1. Let's get it. I really hope you're kicking some butt right now because I know that as you continue practicing, things are going to get easier and easier and easier. So with that said, I got a nice surprise for you. You're clearly interested in this. You're clearly engaged. So what I'm going to do for you is give you an awesome, one-time only discount to my full ASVAB program. The full year, I'm going to give it to you for $100 off, which when we do the math, that's already discounted with an extra $100 off, and that's going to come out to a 73% total discount. So if you're looking to pay as little as possible for all the content that you need to raise your score and get the job you want, use the code YouTube100. That way you can save massively. Can't find this discount anywhere else, just in this one right here. That way you can raise your score and get the job you want. As always, everybody, if you have any questions about this, there's my phone number right there, text only, or you can just go ahead, go straight to the website, click sign up and raise your score, click the year, use that coupon code, and then taste the ASVAB. So with that, let's keep working. You got this. And that is time. My party people, go ahead, put those answers in. Put a question mark next to your answer if it is a guess. Let's see what you got, my party people. Go ahead, go ahead. All right, so it looks like a lot of folks here have very similar answers. So we're either all right or all wrong. And I love these games here because, hey, you never know until I actually highlight the correct answer. So let's get it done here. First things first, read that question. Everybody, what are we looking for? Give me a word or a phrase. Tell me what it is that we're looking for here. When we read the question, what did you write down that we're looking for? All right, so I see a lot of us saying time or hours. I love seeing that. I love seeing that. But are we being specific enough? Because remember, everybody, if we're saying that we're looking for time or hours, what's stopping us from just saying that this is the answer, 18 hours? So let's be a little more specific. Time for what? Give it some context. Give it some story here. What is it specifically? Time for what? Time for me to eat breakfast, the time for me to finish eating dinner. Come on, be specific here. What is it that we are looking for? Yeah, there we go. The time that we spent at the higher speed. So let's write that down right there. So highlighting it, how many hours does the ship spend traveling at the higher speed? So my party people, let's be specific. We want the time at the higher speed. And that's going to be a certain amount of hours. So before we continue, yes or no, hit me in the chat box. Want to make sure you're alive. Are we good on understanding that there are a couple of different scenarios here, but we're focusing on the time in the scenario with the higher speed? Again, the story matters just as much as those numbers do, everybody. The story matters just as much. Next step, we're going to go through the information so we can understand everything that's happening here. So a cargo ship travels from port A to port B, covering a total distance of 1,200 nautical miles. For the first part of the journey, the ship travels at a speed of 20 knots for 18 hours. And for those of you who don't know, 1 knot is 1 nautical mile per hour. Okay, so 20 knots for 18 hours. This is going to be considered a rate. That is going to be considered a time. For the second part, it increases its speed to 25 knots. Again, this is a rate. So when we think about it, everybody, does this situation fit the scenario where the total distance is achieved by getting the distance for part 1 and adding it with the distance for part 2? Is that the scenario that we're looking at here? Just confirm it for me, yes or no. Yeah, the answer here is going to be yes. The answer here will be yes, because we have the first part of the journey and the second part of the journey that will give you the total distance. So that's how we know that what we're going to try to do here actually fits the scenario. It's not like we have two things moving at the same time. No, no, no. We're talking about one thing moving 2 times. So with that, let's go ahead and represent this. Again, the total distance. The total distance, it's going to be equal to the distance for the first part. So I'm just going to say distance for part 1, and it's going to be added with the distance for part 2. Allow me to move this, make this a little smaller, place this over here. So for plus the distance from part 2. Yeah, no worries, Tyler. Again, you learn these things and then boom, we'll get better next time. So the total distance that they gave us, everybody, was what? What was the total distance that was given to us? Yeah, total distance was 1,200 nautical miles. Okay, great. So that's our total distance, 1,200. Then when we try to understand, again, each component, the first distance and the second distance, we just look no further than right here. For the first part, we see that we have a speed of 20 knots and then a time of 18 hours. So to find the distance, we are going to take the rate multiplied by the time. So we are going to get the rate, which is 20 knots, multiplied by 18 hours right there. Then for the next part, we're going to have right over here in, let's grab blue. So for the second part right over here, we have an increase in speed to 25 knots. And so we're looking for the time for that higher speed. How many hours for that higher speed? So we're going to add that right over here. The rate times the time is going to be 25 knots multiplied by the unknown number of hours right over here that we're looking for. Everybody, does this make sense? We wanted to plug in everything we had. We knew the total distance. We know the rate and the time for the first scenario, for the first part of the journey. And then for the second part of the journey, we knew the rate, but we didn't have the time. So that's why this is basically a story that we're filling in the blank to. This is the story written out in math. We wrote down everything we knew, and now we're able to find what we don't know because this is an equation. There's one variable right there. This is absolutely solvable. So for anybody out there who made a mistake or got confused, are we feeling like we're in a better place now? Perfect. Again, that's what I'm looking for. I'm not looking for perfection. I'm just looking for improvement. So again, it just takes that honest look and then trusting me to help you out every step of the way. I got you. So the next thing we're going to do here, again, this is the math part. With this math part, now we are going to go ahead and get a little more technical. So the other way, so Arnav, I love how you're saying that. Another way that you could have done this is you could have just said, hey, let me find the remaining distance and just put 25 times t. So the rate times time equals the remaining distance. To do that, you're actually doing exactly what you see here. We're just going to subtract whatever this is on both sides. And it's going to give you that remaining distance anyway. So just wanted to make sure that for those of you who did that, you know that you're doing the exact same thing that we're doing here. You actually just thought about it in a faster way, which is always good. So yeah, no worries, Laura. You're good. You're actually doing it in a much more efficient way. I'm making sure that it all makes sense to everybody before we try taking shortcuts. So with that, let's go ahead and get it done. 1200 equals 20 multiplied by 18. Let's just go ahead and do 2 times 18, which is 36, and then bring that 0 back for 360. Then we have 25 times t. All right, right over there, and there we go. So let me actually just go ahead and keep that as black, and let's solve. So first step is what, everybody? What are we going to do to both sides? What are we going to do? Yep, we're going to subtract the 360 from both sides. So right over here, minus 360, minus 360. And so we're going to cancel out on the right side. 1200 minus 360 is going to give us 840. If you want to do this with a little bit of mental math, here's how you can do it. You can take 1200 and subtract 300. That's 900. From 900, subtract 60, 840. That'll give you a little bit of an easier time when you split and glue instead of trying to do it all at the same time. So now we have 840 equals 25t. My party people, hit me in the chat box one more time. What's the last step we'll take here? Angelique, appreciate you. Ronnie, you as well. Divide 25 on both sides. Right on, right on. So we're going to take, let's use blue. So we'll divide 25 on both sides. Cancels out on that right side. And so now all we have to do is figure out what 25 into 840 is. So 25 going into 840. 25 goes into 8. It doesn't. 25 goes into 84 3 times. So we'll subtract 25 times 3, which is 75. 84 minus 75 is 9. But before you continue, just double check. Our answer is going to be starting with a 3. Which of these answers start with a 3? Right here, B and C. So everybody, do we have to continue going to make sure we know what the answer is? Yeah, we do. Because we have 2 answers that start with 3, so we can't just stop right there. We have to go ahead and continue on. We can't be lazy about it in this case. So we'll drop that 0. 25 goes into 90. How many times? That's going to be 3 again. 25 times 3 is 75. So we'll subtract 75, and that's going to give us 15. And so then from there, my party people, we can go ahead and place a decimal if we want to, or you can notice that our answer starts with 33. We take a look at the choices. Is there only one answer that starts with 33, everybody? Yeah. So this is a test-taking strategy. You don't always have to complete the calculation to know what the final answer is. If all of your answers are different, if you know that your setup is correct, then all you got to do is just kind of do a little bit of the actual math, and you might be able to tell what the correct answer is. This won't happen all the time, but sometimes it will. So with that said, everybody, I can zoom on out there. If you wanted to continue trying to do the division, we would drop another 0 right over there. And 25 goes into 150 exactly 6 times. And that's how we would get the 33.6 hours. But with that, everybody, you tell me, do you feel like you got a little better at, again, understanding the setup right here? All right, for those of you who are saying yes, I'm glad. For those of you who are saying no, we got to see what we can do to move forward. So at this point in the class, this is where I'm going to be very honest with you. If you're feeling like the lesson, the concept, and the math that we're doing really doesn't make sense, then this is where it's totally okay to admit that we still have to refresh and solidify those fundamentals. So if you haven't finished the math basics yet, if you're in the program and you haven't finished it yet, and you're struggling right here, then it's perfectly okay to admit that, hey, look, maybe there are a couple of things that we got to do before we can achieve the confidence in this space. So after this class, for those of you who are nervous about the math, nervous about the decimals, to the point where the word problems don't even make sense, make sure work in order in the math basics. All of these recordings, they're all already organized in the Arithmetic Reasoning progress book for you. So whenever you're ready, it'll be waiting for you. You're good. I want you to focus on making progress the right way, so that way you spend less time being confused and more time building that confidence. So just want to make sure I put that out there, because I want to make sure you understand why you may feel certain ways and what you can do to put yourself in a more empowered position. So with that, my party people, are we good on that? Are we ready to move forward to the next question? Oh, and thank you guys. I appreciate that. I want to go ahead and just read some of these comments here. So I'm glad you're getting better running each day. Townsend, you found the mistake that you made. Zoom, you forgot, or you don't know how to split and glue. Again, that takes time with the math basics. Gerald, you get it now. You see where you're messing up. You just keep forgetting to subtract in this specific scenario. Leslie, I appreciate you. You're saying you just need to improve on the math basics. Right on. Laura used to be bad at math. You're never bad at math. You just didn't have the experience. But since you did the math basics, you feel a lot more confident with your understanding. That's what I love to hear. So, just take that example, everybody. I want you to know how to work in order in the right way. So with that, let's go ahead and set the timer right back up. Here we go. Next question. I'm not telling you what kind of question to expect. You just got to go ahead and take a look at it and kick some butt. So here we go. 3, 2, and 1. And that is time. Everybody go ahead, put those answers in. Put a question mark next to your answer if it is a guess. Right on, my party people. All right. So again, we're either mostly correct or mostly incorrect. Let's go ahead and check it out. So first step, read the question. Let's give ourselves the chance to really understand the situation as a whole. So right here, the question is, what is the total distance the cargo ship travels from port A to port C? All right, sounds good. So everybody, again, in a phrase or a short sentence, what is it that this problem is telling us or tasking us to determine? What are we trying to find here? Go ahead, explain it to me. What is it that we want to find? We read the question, and so iPhone, you're saying total what? Total time, total rate, total distance. Total distance. So we want to give ourselves that chance to, again, explain or articulate what we're looking for. And Tyler, I just saw your comment. I love hearing that. So next up, let's go ahead here, highlight that. What's the total distance? And again, port A to port C. So everyone, when we read through the scenario, it says that the cargo ship travels from port A to port B, and then from port B to port C. So is it fair to say, everybody, that if we're looking for that total distance, give me one moment, looks like we're having a little bit of lag there, perfect. So if we're looking for that total distance right over here, isn't that gonna be the distance from port A to B plus the distance from port B to C? Isn't that gonna be the case? Isn't that what the total distance is going to be? Like, if we're just talking about this in straight up terms of the story, to get the total distance from A all the way to C, we got to figure out A to B first, then figure out B to C, add them together, and we're good. All right, so okay, cool. Looks like we understand that. Now let's go ahead, zoom on out here, and let's gather the information. So during the first leg of the trip, let me actually remove this as a red highlight. So during the first leg of the journey, again, port A to B, the ship maintains a speed of 22 knots for 14 hours. So if we're looking for the distance from A to B, well, that's going to be the rate times the time. So that'll be 22 times 14. That's what that'll be. That's the rate right over here. That's the time right there. Let's figure out what that is. Let's zoom on in. Let's do 22 times 14. 22 times 14. 2 times 4 is 8. 2 times 4 is 8. Next line, 2 times 1 is 1. Or 2 times 1 is 2. So with that, we have 88 plus 220. Add all that back up, and we are good. 8 plus 0, 8 plus 2, and then 1 plus 2 is 3. So our distance for A to B is going to be 308 nautical miles. Do we agree with that, my party people? Yes or no? Right on. So we have 308 nautical miles right there. So now let's do the work to figure out the distance from B to C. So that's what I'll highlight in blue. The second leg, port B to C, the ship increases its average speed to 25 knots and travels for 16 hours. So as we write that out over here, we're going to have the distance from B to C. We got some lag again. One moment. There we go. So the distance from B to C, that's going to be the rate times the time, which is 25 knots times 16 hours. Again, the rate times the time. So from here, once we do that, let me give myself some room to do that over here. So we have 25 multiplied by 16. 5 times 6 is 30. 2 times 6 is 12. Carry the 3 is 15. Then we move over to the next line. 5 times 1 is 5. 2 times 1 is 2. Add that all back up. We have 0, 10, carry the 1. And then we have 1 plus 2 is 3. Carry the 1 is 4. So that's going to be 400 nautical miles for the second leg. So now all we have to do to get that final answer, to get that total distance, let me zoom on out appropriately here. So all we have to do now, my party people, is add this up. So everybody, 308 plus 400, that's going to give us a final answer of what? Yep, 708 nautical miles. Who feels like this is a very, very much more easier process than it was before? Just let's just put it that way. Who feels like this is getting easier? And like this is what I'm telling you guys when it comes to improving your ASVAB score, it's just a ton of different concepts that we want to learn how to think logically about. And it takes time to learn all of these concepts. For anybody out there who has their test scheduled for this week or next week, and you just started the program or you just started studying, like if this is making sense to you and you're feeling good about this, imagine what's going to happen when you actually take the proper amount of time. I never recommend taking the test if you're not ready. Just want to make sure I remind everybody that you are in control of your test date. So with that, there it is. Our final answer is 708 nautical miles. Let's be proper here. Nautical miles. And there we go. There's our final answer. It's C. Right, Paulina, or yeah, I saw the private message there. So I think it's so surprising how the questions are less scary now, even with all the words. Yeah, that's exactly what I'm trying to point out to y'all. Things get easier when you have experience. So let's move forward to the next one. So here we go, my party people. Let me go ahead and find it here. All right, here is our next one. The timer is on the screen right over here. And here we go, my party people, in 3, 2, and 1. And that is time, everybody. Go ahead, put those answers in. What do you have? What do you have? Go ahead, give yourself that chance, everybody. All right, so let's go ahead and get that timer out of the way. And as always, we're gonna just try this out faithfully. We're gonna give ourselves the best chance that we can. So let me get the timer out of the way. Right over there. All right, cool. So let's get to work here. First things first, we wanna understand, hey, look, what are we looking for? So here it says, how long does the drone take to complete the return journey? Sounds good. So how long does it take the drone to complete the return journey? Everybody, is it clear here that we're looking for the amount of time that it takes for the return trip? So specifically, again, we're looking for time, and the context, the story, is that we're looking for the time for the return trip. Yeah, on the way back. Exactly. So with that, boom, we understand what we're looking for. We're looking for the return time. And that's going to be a couple of hours. However long that is, that's what we're looking for. So with that said, let's take a look at the information and let's see what's going on here. Let's see what information we have to work with. So starting from the beginning, a delivery drone completes a round trip between two cities, covering a total distance of 450 kilometers. Okay, so if we're talking about this delivery drone, it starts over here and it's going to go around the city. So it's going to go between two cities. So we can say something like, hey, we have part one like this, and then it hits this city, and then part two, the return trip coming back, something like that. So everybody, if we're looking for the total distance, that's going to be first trip, second trip together, and that's how we get the 450 kilometers there. My party people, does that make sense? When we think about the total distance in this case, we are thinking about the first part of the trip and the second part of the trip added together. All right, cool. Because remember, I always want to justify why it's going to make sense when we say that the total distance is going to be the first distance plus the second distance. I want to make sure that makes sense. So the total distance will be the distance to plus the distance on the return trip. So I want to make sure I separate both of those. Is everybody okay with the way that I wrote this? The total distance is the distance to the deliveries and the distance for the return trip from those deliveries. All right, so if we're good with that, now let's go ahead and plug in what we know. So again, like we said, that total distance right over there, that's going to be 450 kilometers. We'll write that in, nice and easy. Next up, we are going to try to find the distance to. It says on the outbound journey, it flies at an average speed of 50 kilometers per hour for 3 hours. And then on the return journey, we have a favorable wind, so we can go a little faster, 75 kilometers per hour. So let's go ahead and get that done. So the distance to, we'll mark that in blue. So the outbound journey is what they describe that as here. We have the speed of 50 kilometers per hour and the time as 3 hours. So we can plug that in to get what that is. So the distance to will be 50 times 3. Everybody, 50 times 3 is going to be what? Yep, 150. Nice and smooth. So there we go. So from here, we are going to take a look now at the return trip. So the distance for the return trip, we see that we have the speed for the return trip is 75 kilometers. So the only way that we can write this right now is the rate times the time, which is the rate of 75 multiplied by the time that we're looking for. So at this point, my party people, in the setup process, this is the point where we'll be able to realize that we have everything we need to solve. We have made an equation that represents the story, and now all we have to do is go, hey, let's figure out what this equation solution is by working backwards. And so the first step that we'll take, like you guys have graciously said in the chat box, yep, we'll subtract 150 from both sides to start. So everybody, what's 450? Take away 150, what do we get? Yep, that's going to be 300. So 450 minus 150 is 300. 300 equals 75t. And so from here, my party people, 300 equals 75t. We'll divide 75 on both sides. Yep, giving us right over here and over there, causing a cancellation on the right side. And so from there, we will have t equals 4, because 300 divided by 75, that's a perfect 4 times. The way you might be able to see that is half of 300 is 150, half of 150 is 75. Cutting in half twice is the same as dividing by 4. So that's going to be 4 hours. And if you need confirmation, you can always do 75 times 4 just to make sure that that makes sense. 5 times 4 is 20. 7 times 4 is 28. Carry the 2 is 30. Giving you a final of 300, confirming that it works. And so there we are, my party people. The answer for this one is C. Alexa, feeling like you're actually getting it? There you go. Like that's the, that's what we're trying to get to. The point where it's not just math, a vomit-inducing swirl of words and numbers. No, we want to get to the point where we look at this and we're excited because we're problem solvers. We know that we can organize the information in a way to actually figure out what the answer is. So I'm proud of y'all for, again, continuing to put yourselves through that grudging beginning so you can have that confidence here at the end. So we have time for one more question. Let's see if we do. Would you guys, let me see here. Yeah, we have time for one more. Would you guys like to try one more? All right, let's go ahead and go for it here, my party people. Here we go. In 3, 2, let me get the timer up for you first. Sorry about that. So here you go. Here's the question. Timer is starting now. Let's get it done. And before I solve this question for you, my party people, what I need you to do, go ahead, drop a comment on this video, letting everybody know if or if not, this is helping you out. I want your honest opinion because I want to make more content to help you succeed. And as always, once you're done commenting, watching the solution, and ending the video, then go ahead, sign up, show up, and raise your score with my ASVAB All Access program. Again, this video is the only video where you'll find this insane discount YouTube 100. It'll give you $100 off my full year. The options are monthly, 3 month, 6 month, and the full year. And if you use that discount code, it'll drop the price of the full year to where you're basically paying 3 months and getting the rest of the year for free. It's a huge discount to make sure that you have every opportunity to raise your score and get the job you want. As always, I'll be right there with you every step of the way until you pass. So avoid the test anxiety, avoid the confusion, and sign up and just make your enlistment so much easier. I got your back, everybody. Coach Anderson here, and let's get to the solution. And that is time, my party people. Go ahead, put those answers in, put a question mark next to your answer if it is a guess. Yeah, so this one's a new one, isn't it, right? But it's still the same premise, everybody. Still the same premise. So we are still dealing with a combined total distance where we're looking at two events. In the first event that has its own distance, rate, and time. The second event has its own distance, rate, and time. Let's see if, even if this was a little confusing, let's see who was able to pull through, and let's also see who's able to learn from any mistake that you might have made. I got you. So first step, read the question. What is Alex's average speed on the local roads? My party people, before we get started on all the fun, before we get started on having fun, is it clear that we're looking for the speed on the local roads, not on the highway? All right, sounds good. So here we go. We'll write that down. We are looking for, again, the rate on the local roads. That's what we're looking for, and that's going to be given to us in kilometers per hour. That's what the answers say. So let's read through everything. And again, let's confirm that our method to solve this is going to make sense. Alex is on a road trip. He starts his journey by driving on the highway at this amount of time, this much speed. Then he gets off the highway and continues on local roads. The total distance for the whole trip, they give it to us here. Highway and local roads combined right there. And the total time spent driving is 4 hours and 30 minutes. Okay, sounds good. That's a lot of information. So who here felt completely overwhelmed with all of this information? Again, be honest. I want y'all to come out of the woodworks there. Be honest. Let me know, because the goal here is to set ourselves up for that light bulb moment. So again, admit that you're lost. It's all good. Now, to yourself, I want you to think about the point at which you got lost. Watch this. Everybody, let's start off by making some basic sense here. Isn't it true that if they gave us right over here, this total distance, so the total distance that Alex travels at 280 kilometers, isn't it true that if they give us the total distance for the highway and local roads together, isn't it true that to get the 280, that would be the distance for the local roads plus the distance for the highway? Isn't that going to be just adding the distance that we get for local roads and the highway together? Isn't that all that's going to be? If we think about it in its simplest form? Yeah, right on. Okay, cool. Again, in the simplest form that we can think about it, in the most sincere form, this is what this would look like. Now it's our job to fill in the pieces of information and find anything that they may not give us, because that's what's happening here. Watch this. The total distance, we know it's going to be 280. We just got done reviewing that. That's right there. But that's not the hardest part. The hardest part is understanding how to get the distance for the local and the distance for the highway. Everybody, here we go. Read back from the beginning. He starts his journey by driving on the highway. So let's use blue for that. So driving on the highway for 2 hours at an average speed of 80 kilometers per hour. Everybody, if I wanted to represent the distance for the highway, we can just represent it as the rate times time. Is that fair to you? Sounds good. So the distance for the highway, that's going to be the rate times the time. So that's going to be 80 times 2 hours. So that's going to be 160 kilometers. Everybody, do you agree with that? You can replace the distance on the highway with 160 kilometers. All right, so far so good, right? This is where the tricky part comes in. All we have to do is take it just a little slower, everybody. So think of it like this. If we want to figure out the distance for the local road, we can go ahead and set that up as, again, rate times time. We're looking for the rate. So I'm just going to go ahead and write the rate right over here. Let me use a red highlight for the local roads. So I'm going to put R for the rate on the local roads. Is everybody okay with that? Sweet. Now, the bigger question is, what the heck is the time? What is the time? What is the time on the local roads? How do we get that? Here's the hint, everybody. Here's the hint. I'm going to highlight it in green. Here's the hint. The total time we spent driving is 4.5 hours. That's the total time we spent driving. Everybody, if we spent 2 hours on the highway and 4.5 hours total, what's the in between? How much time do we have had to spend on the local roads? The clues are right there in front of you, everybody. To get the time that we spent on the local roads, you can take the total time that you spent driving, 4.5 hours. Again, 4 hours and 30 minutes. That is the same as 4.5 hours. So that's 4.5 hours total. If we subtract the 2 hours on the highway, we will end up with 2.5 hours left, and that is for the local roads. My party people, does this right over here, does that make sense in terms of how we found the time that we spent on specifically the local roads? That was the biggest key for a lot of you. I know that for sure. So that's what you were missing. Perfect. So with that, that's what you want to plug in for the time for the local road, 2.5 right over here. So again, just to recap what just happened, we were making sure that we found the right information. We had the total distance. We were easily able to find the distance on the highway, but to represent correctly, to represent the local distance, we need the rate for the local distance, which is what we're looking for. That's the question. And we needed the time spent specifically on the local roads. So to do that, we knew that we had a total of 4.5 hours. We took away the 2 hours from the highway to reveal that we spent 2.5 hours on local roads. Now that we have that, boom, that's it. We're done. All we have to do is solve and we're good. So now I'm going to speed up the process because time is pretty much almost over here in class. So we have 2.5 R plus 160. The first step will be to subtract 160 on both sides. Once we do that, everybody, we're going to leave ourselves with 120 equals 2.5 R. The last thing that we'll do to both sides is divide both sides by 2.5, which will leave us with 120 divided by 2.5, which will leave us with 48. Once you do the math, that's going to be 48 kilometers per hour. And there you go, my party people. There is your answer. B would be it. Thanks for watching the video, my ASVAB party people. As always, make sure to comment if this helped you out. That way more people can get the content that you deserve. They deserve it too. That way everybody can succeed. And as always, hey, look, you made it to the end. You're clearly interested. I offered you a massive discount code to our full access program. That way you can work on your schedule with all the classes and the recordings. You can track your progress every single step of the way with tens of thousands of practice questions. And then you can absolutely make sure that you're test ready with our practice tests for the arithmetic reasoning, math knowledge, word knowledge, and paragraph comprehension with step-by-step solutions. We've got your back every single step of the way, everybody. I have a master's degree in teaching, and I've been leading the way for over 5 years here in the ASVAB space. I'm Coach Anderson. I love y'all. Like and comment, subscribe to the channel, and I'll see you in the next video. Cheers.